Hello subscribers. So let us continue with our next topic, which is circular shift operation. So circular shift operation is one of the parallel communications जहाँ पे every processor sends its data to another processor shifted by a fixed number of positions. यहाँ पे the fixed number of positions is defined by the letter Q. This is defined by the formula mathematical expression I plus Q mod P, where I is the current processor, Q is the shift value, and P is the total number of processors. So let us take an example. There are 8 processors and fixed shift value is Q is equal to 1. So for example, if we take 8 processors and let me change this value, just a second. Shift value is 1. So by the formula we can say I plus Q or P. So processor P0 is the first processor and shift value is 1. So next processor will be P1. We know the fixed value, shift value is 1. So next will be P1. Now from P1, next shift value will be P2 and so on till P7, जहाँ पे shift value will return to P0. This is what it means by circular shift operation. Suppose there is a round table. There are 4 people on the table. It either shifts in counterclockwise or clockwise or counterclockwise. Next, we have types of circular shifts. First one is the ring topology. In ring topology, the data moves in clockwise or clockwise direction, where the processors are connected in a circular form and each processor has 2 neighbors. So this is the current processor and it now has 2 neighbors. Next we have the mesh topology. In mesh topology, the processors are arranged in rows and columns, unlike ring topology. And shift operation takes place in phases. So in there are basically 3 phases. First phase is the row shift, जहाँ पे rows में से shift होता है, and next is the column shift. And final phase is the final adjustment. And third and last is the hypercube topology, जहाँ पर shift operation is performed dimension wise. So dimension wise, we can understand that with an example. For example, suppose we have Q as phi and in representation P rep. Binary representation of phi is 0, 1, 0. How is this possible? We can say this by 2 raised to 2 plus 2 raised to 0 is 4 plus 1, giving you. So there are two phases. Phase 1, where shift takes place in 4 places, and phase 2, where shift takes place by 1 place. So for example, there are 8 processes, P0 till P8, P7, suppose P0 to P7, 8 processes. In first phase, phase 1, shift takes by places P0, P1, P2 and P3. We have 4 pieces shift, so this will take place at P4, 5 and P6 and 7. यहाँ पे आपका phase 1 complete हो गया. Next phase we have phase 2, where shift takes place by continuing this phase 4 by shifting one place P5 process. Similarly, P5, P6, P7, P7, 0. This is what circular shift on Hypercube suggests, where processors communicate dimension-wise and shift Q is converted into binary in binary representation, and we find out the number of phases. So in this case, 2 phases are required for shift. Next, moving on to the applications, we have parallel sorting, scheduling and data distribution in cases of circular shift. We have completed this part. Moving to the next topic, we have blocking communication in MPI. Before starting with blocking communication in MPI, let us see what MPI is. MPI is basically message passing interface. So इसमें basically this is a standard protocol that is used in parallel computing so as to communicate between the processes by sending and receiving the messages. So in case of blocking communication, यहाँ पे the processor waits until the communication is finished. इसका मतलब ये है कि process is running and waits until the communication is fully completed before it moves to the next example or instruction. Example, suppose you send a parcel and stand at the post office until the delivery is confirmed, और जब तक डिलीवरी कंफर्म नहीं होती है यू कैनॉट डू अदर वर्क. मतलब आपका प्रोसेस चालू है लेकिन कंफर्मेशन नहीं मिला है एंड यू कैनॉट मूव फर्दर. दिस बिहेवियर रिप्रेजेंट्स ब्लॉकिंग कम्युनिकेशन. इसके फंक्शंस MPI send function. This is used for sending data. The receive function recv used for receiving data. What are its advantages? Because of this, sometimes the process remains idle. There is a lot of time wastage and there is possibility of deadlocks as well, or CPU ka utilization and usage will be very poor. And its advantages are it is very easy to understand, easy to debug, and simple programming. Next we have the non-blocking communication in MPI. So in non-blocking communication MPI, the process is little different. In this, the process does not wait for the message to complete. What I mean is, the process does not wait for the message to complete. That means communication starts immediately, not wait, and process continues executing other tasks, irrespective of any other communication or other process. And communication occurs in the background simultaneously. Are its functions? We have the MPI iSend, which is the non-blocking. So what it does is this starts messaging, sending the messages, but does not wait until it's done. To check if the task has been completed, the MPI wait to check whether the task has been completed. Task completed or not. We use MPI wait or MPI text, either of them. And next we have MPI receive, which starts receiving the messages and continues executing other instructions while data arrives. Incoming messages will take place and it will receive the messages irrespective of any other process. Real life example, order line and continue working while delivery is in process. That means you do not get idle. You will complete your work and complete your given task till the time your food arrives. This presents non-blocking communication. Advantages is CPU utilization is being improved and communication overlaps irritation and reduces idle, gives and provides better performance compared to blocking communication. They have comparison between blocking and non. So in block, it waits for the completion of the task where it continues execution simultaneously. In non-blocking, blocking is very simple, as non-blocking is pretty complex. And blocking models, CPUs remain idle. There is a possibility, whereas in non-blocking there is better utilization of CPU. In blocking, better performance, whereas in less. I'm sorry. In blocking there is low performance because CPU is not being utilized well, whereas in non-blocking there is higher performance compared to blocking. Next, we have the communication cost analysis. So why do we require communication cost analysis? So as to calculate the time required for the processes to exchange data in parallel computing system. I repeat, calculate the time required for processors to exchange data in parallel computer system. So communication cost analysis measures the time required for the communication. Why is it necessary? This is necessary so that the processes may be fast, but communication between them can still slow down the program. and we need to analyze them so as to how much time communication takes and where delay occurs. And to calculate this, we standard formula: total time is equal to startup latency plus transfer time per word multiplied by message size. Let us find the formula. Startup time is basically the fixed head before communication begins. I'll give you an example. So there is a courier service. A person books or does the booking. The person is doing the booking time, and that booking time is equal to the startup latency, whereas the actual parcel he receives or the actual delivery is the transfer time. So total delivery time will be booking plus transportation. Next we have the transfer time TW divided by M, where the actual data transmission time takes place, and messenger message means high communication time. Cost analysis matters. It matters because so as to compare the topologies and design efficient algorithms for future prospects and to reduce bottlenecks and improve scalability. Next, the improving communication speed. Efficient communication is necessary because communication overhead reduces parallel performance, and there are several techniques to improve the communication speed between parallel computation processors. For the messaging, the message divided into small chunks. What is the advantage of this? For transmission, is better overlapping, reduced waiting. One of the examples is instead of transporting all goods in a truck, use multiple smaller vehicles. Delivery becomes faster. Next, pipelining. Data chunks move continuously through processes. While one chunk is transmitted, next chunk preparation has already been started. Then we have non-blocking communication. Communication and computation occur simultaneously in non-blocking to blocking communication, which we had seen earlier. And then we have efficient system where messages follow the shortest path. What is the advantage of this? We get lower delay in receiving the message, and there is better network utilization and reduced congestion. Next we have load balancing, where communication load should be distributed evenly in order to prevent bottlenecks and avoid overloading one processor over the other. That's it. Let us take a quick revision or summary what we had discussed in in this few in this few lectures. We have seen broadcast where one processor sends same data to all. Next we have action where many processors combine data one and serve different data distributed to different. So then we have the where different data is collected at the. Then we have prefix sum, cumulative addition operation, and then we have shift, data being shift among the processors. Then we see in blocking non, where in blocking communication pervades during communication and processor works while communication happens in non-communication, and its cost formula is total is equal to TS plus TW multiplied by M. I hope you like the video and don't forget to like and share and subscribe. Thank you.